Hi guys, can you see me? Can you hear me well? Can you guys tell me what happened when I done at the red general in WhatsApp? Like, did you all get a notification as if you were pinged? Ever thought of falling when you had a few? 'Cause I always do. Do we have viewers? 10 viewers are needed. I told 3 or 4 as a joke, but we need 10 at least. We need 10. I was listening that song just now. They will keep copyright if I play songs. Have you got color on your cheeks? Do you ever get that shift? So, guys, we have 9 viewers. I hope we have 10 viewers now. So, what I'll be solving is. It's not nihilist, no. I don't think it's nihilist. I haven't watched. Okay, I haven't started CP. Like the video, guys. I'll share the screen because we have 10 viewers now. You guys haven't responded to what happened when I pinged you people at the Red General. Oh, we have too many viewers. So we'll try LeetCode 16. LeetCode 16, like LeetCode week. I mean, LeetCode problems of the week. So from when should I start? Last Friday or Monday or Saturday or Sunday or Monday. I'll give you guys options. From where should I start? Like problems of the week should be for 7 days at least, right? So should I start from last Friday problem and then just solve all of them? Afterwards, see if I'm not sure if I'll do that. I'm doing this for my LeetCode viewers. That I will try later, maybe at the end of the month. After 10, I'm in second year diploma and I also want to be a competitive programmer. Can you please tell me what maths do I need? See, when you guys tell what maths do you need, if you guys have done 7th class math in a proper way, that would also help you guys. Like it's not like it's doing what you're doing properly, okay? It's not like some specific topics or some specific things. Even in 7th class, we have nice things like how do you prove 180 sum of angles in a triangle as 180? Sure, I'll close this WhatsApp tab and then I'll share screen. You guys see my screen? I'll start from Friday, last Friday. We got most votes to the last Friday. So yeah, mine was 2020. I got in paper 1 I got 120 marks, whereas Air 1 got 196. In paper 2 I got 159, more than Air 1. He got 156 or something. Mm, 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 mm. I got 102 rank with that. So from 6th February to 13th February would be bad. I'll start from 7th to 13th. I'll complete today's one too, and I'll start from 7. Week should be only 7 problems, right? So we are here, guys. You're given a string as minimum deletions to make string balanced, okay? I just bathed right now. That's why I think I look a bit better. I just bathed. I just took a bath. After a while, I took a bath. Minimum deletions to make string balanced. You are given a string as consisting only of characters A and B. You can delete any number of characters in S. Can you guys make a thumbnail for me that says week problems of the week or something like that that I can put up here? I have to make such a template like thumbnail so that people will watch, especially LeetCode viewers. They click based on thumbnails, I believe. You can delete any number of characters in S to make S balanced. S is balanced if there are no adjacent, no pairs of indices I, comma j such that Si equals to B and Sj equals to A, I less than J. What does this mean? You should never have a B in front of A. That's what it means, right? Return the minimum number of deletions need to make S balanced. What is a you can delete any number of characters in S. So what is this problem saying? You cannot have a B in front of an S, right? Can you brute force the problem. First think like, can you brute force the problem? Look at optimal. Okay, optimal cannot have a b in front of a. So what does optimal have? Optimal have b, a. Yeah, some things have been removed. Yeah. Some things have been removed and B. So look at optimal is a very basic step that anyone can do, right? Looking at optimal. Now let's look at optimal, and if you look at optimal, there is a point where in front of which all are A's and after which all are B's. So if you look at optimal, there is a point like that. Can you brute force that point is a question that you can think of, right? Before thinking how to solve this problem, before thinking algorithms like, can I remove all A's, can I remove all B's? Is there a greedy way to think of this problem? Just look at optimal now, because you have to apply logic. To apply logic, you have to say, okay, let's say these things are the ones that I have removed, and the leftover things will be consecutive, not consecutive, some sequence of A's and some sequence of B's, right? Such that there is no b in front of it. Rather than thinking of algorithms, think about the problems before. Okay, because you are given a problem and you have to also prove that this is optimal. Okay, you have to prove that this is optimal too. Like you don't see, that's all the problem is with you people. You try to get some algorithm before trying to solve the problem. You throw away the problem. If you don't throw away the problem, looking at optimal is one of the basic things you can do. And if you look at optimal, you can see that there is a specific point where in front of which we have A's, in front of after which we have only B's. Can you brute force that point? Think about that now. Okay, if I'm trying to brute force that point, how to solve the problem? Let's say that point is this one. So now how many x's we will remove? Everything that is B before that has to be removed. How many x's we will remove after this? Everything that is must be removed. So if you can brute force that one, the last A or that last partition, the problem is done. Okay. So what all we need? We need number of B's before this. We need number of A's after this. So I will store this one in prefix sum, and I will store number. So we will store number of B's in a prefix sum, and then we'll come from this side. We will know number of A's to be removed, and then we will brute force that one. So what are we brute forcing? Brute forcing the partition. There is a partition. We are trying to brute force that partition, and then the problem is done, right? Once that partition is brute forced. So you guys are learning the wrong way if you are trying to get some algorithms before trying to solve the problem by throwing the problem away. N equals to s dot size of. Let's just maintain prefix of n. That gives us number of b's still here. Okay. So what is pref of 0? S of 0 equals to b. For int I equals to 1, I less than n, I plus plus. Pref of I equals to pref of I minus 1 plus s of I equals to b. So far it's good. Okay. So we got this one, and then what should we do? We have to come from behind, and then we will find number of A's. Okay. Let's say initially number of B's. Removing all B's is an answer, right? If you're removing all B's, this is an answer. So this is initially the partition being here. Now we will move partition here up to so on n times. That will come till here, and then we'll solve the problem. How do we solve the problem now? Int I equals to n minus 1. I equals to n minus 1 is before n minus 1. Okay. Till n minus 2 things. Okay. I'm trying to kiss you. So where are we? We are here. And then we want number of s. Count s equals to 0, let's say. Okay. And now we are moving our partition from here to here. Okay. We're moving our partition from here to here. And then what will happen if you do that? Ca plus will become s of I equals to a. So now we have counts of s after partition. After partition, you have Ca. You need number of things before partition, and this is the index of the partition, right? You want number of things before that. How do you get that? Int before b equals to, let's say, okay, cb equals to, let's say, cb equals to before this one. If I equals to 0, that is 0. Else, it is pref of I minus 1. That's it. So now we have Ca and Cb. Answer equals to minimum of answer comma Ca plus Cb, because those are the things that you are removing, right? So that problem is that easy. Like, you just have to notice that if there are no b in front of you, there is a special partition. Like, how difficult is it to say that there is a special partition? It's not difficult, right? It's not medium, right? Sorry. It's it's easy. It's not medium. Okay, maybe it's medium, like because we are getting errors, and we have two hints, and then we have logged companies here. Damn. Oh, Google, Amazon, everything's floating. Can Google sue these people or something like that? Why are you putting my logo over here? Let's subscribe. See, you guys should be charged to subscribe to my YouTube channel. I'm just kidding, guys. Just subscribe. It's free. Most popular. Premium. Do you guys think I will buy this for my kids in future? Of course not, right? So why would you let your parents buy this for you? I'll make them subscribe my YouTube channel though. I am using Claude a lot. Like the video, guys. This shit is not for free, okay? Where are problems? Did I miss them? I talked too much shit and then now they are not letting me see the problems. Yeah, we have to submit this again. We want maximum length of A and then we have to put that here. Define, or I can make it vector. The answer. What might be wrong? I don't think I made anything wrong. This looks very clear, right? What can be wrong here? Answer equals to CA plus CB, CB equals to I equals to 0, 0, then otherwise you have this one. There is some error here, guys. Just help me out with that. Can you guys see error? It's like Dora. Are you guys able to see the error? Say now. What did you mean by that? Hasn't it as maximum? Which line? Which line is the error? We need 50 watching. We had 50 people watching in a long back ago. Actually, because I stopped streaming much, what happened was my audience has been reduced a lot. If you guys see over 90 over lifetime, here it was peak 15, almost hitting 18 or something. Now it is 7.3. Because I was posting more frequently here. Here I was like posting less frequently. This is correct, right? Removing all this is an optimal solution. So this is right. Is one of the possible solutions. And We are covering all possible solutions to get our maximum value. Let's output and see. Debugging is not easy, is not difficult, right? Is pref of CB is being too bad. CB is being zero all the time. That's not true, right? This shit is not true. CB is having wrong somehow. What the hell? Is this an error? Am I new to programming? How did I miss this one? Yeah, so that's accepted. So one is done, guys. We are heading to Sunday. Saturday is done. I have Excali draw. And then the nights were mainly made for saying things that you can say. I should sing some other song. This shit is getting. So what the problem was, few things have been removed, and then there is a special thing called a partition. We brute force that partition. We brute force that. Okay. Now we'll go to problem, second problem. Sorted as done. I'll write all days and then I'll cross over them. Just for fun. Oh, Sunday comes in between. Lol. So to follow the style, let's make it like this. I remember this. Damn. So this is done, guys. This is done. So yeah, let's go to next problem. Is this Saturday? Let me go outside. Where is calendar again? What the hell is this? I want to solve weekly questions. Like, where is calendar? I have seen calendar before. Problems. Minimum deletions to make string balance. This is what we solved. Now we will solve balanced binary tree. So that was right. This click was correct. Given a binary tree, determine if it is height balanced. What does height balanced means? Each subtree should have each subtree should be height balanced. And what does height balanced mean? Okay, all of its subtrees should be height balanced, and the left side length of left side minus length of right side should be at most one. That is height balanced. They are not even giving the definition of height balance. Okay, they gave here. Is a binary tree in which depth of two subtrees of every node never differs by more than one. Yeah, I told it right, because we have a red black tree, red blue tree, or like we have these sets, right, where we do rotations and then we will make them always balanced. That's how binary search trees are maintained. Okay, when you add things to binary search trees, you will do a rotation and then you will make it again balanced. That's how we can do everything. Set operations involve log n. So we have to just check if it is balanced or not. It seems like it's likely recursion, right? So you have to write a recursive function that does work for you. And in writing recursive functions, you have to define what the fuck will your recursive function do. Okay? So what will your recursive function do? Let's say you're trying to write a function. Okay? If your function returns you the height of the subtree, and if the tree is balanced, you are done. This is enough. If you can write a recursive function that returns you height of this one and also says if it is balanced or not, then you are good. So now this is our recursion like it returns the height of the subtree, and it also says if the tree is balanced. Okay, maybe you can write it like pair of bool comma integer. Bool says if it is balanced or not, and integer says this or not. Now given a root, is this recursion, is this function, is this information enough to form the recursion is the next question. You have to think about this next question. Is this information enough to form the recursion? So given a root, you have its left, you have its right. Now you apply recursion function, and then you will get this one's height, you will get if it is balanced or not. You will get this one's height, you will get this one's balanced or not. So what is the answer? Now left is balanced and right is balanced, because we need not go over all of left subtrees now, because if left is balanced, all the subtrees already satisfy this shit. And absolute of height of left minus height of right less than or equals to 1. So this information is good enough to find the next information, and this information is for the bool. And what about the height? Height equals to 1 plus max of hl comma h or. That's it. So this information is enough to proceed further. And what about edge cases? If root is null, it is balanced and height is 0. Okay, this is like final case. Root is null. Oh, we will use some other recurrence because we don't want bool, right? What we want is pair bool comma int fun. I thought fun is for fun. Maybe it's for function. I don't know exactly what it is for. If root equals to null means it's an empty one. You can try to extrapolate, or you can try to see based on what it should be and return that answer. It should be true because it is balanced, right? And then it should be 0. Now what do we do? Pair bool comma int left equals to fun of left val, let's say. Is that how we access that? That's how you access that. Values doesn't matter, right? Because it's only about height balanced. Values are just there, but it doesn't matter. They don't matter. And if you wanna, every node will at max be touched once. If you wanna understand the time complexity, it's O of number of nodes, because you can see here one operation has happened and then it's O of size of the previous one. Let's say time complexity is T of size. Okay, equals to, we have done one operation. We will do some constant number of operations here plus T of size 1 plus T of size 2. Right, and size 1 and size 2 are smaller values, so it's like linear. If you see in terms of size, it is linear. Bool balanced left equals to left val dot first, let's say, balanced right equals to right val dot first, let's say. Okay, int hl equals to left val dot second, let's say. hr equals to left val dot right val second, let's say. So now what do we return? Bal L and Bal or ball. Don't make conspiracy theories like this guy uses ball in his programming. Oh, but this is ball, not ball. That's fine. That's good. This is just ball. Ball is ball, not ball. And ABS of H L minus H R less than or equals to 1. Comma 1 plus max of H L comma H R. That's how ID is defined, right? Type should be bull. Whoa, why are they so much desperate with money? Why do they want to click a button to just run this thing to run a like to run a checker on a solution? They are like asking for money, and people are still using this shitty site. So guys, take the red color now and cross off Sunday. Where are we? What have we done in this problem? What have we done? Wrote a recurrence. Okay. Brute forced a partition. It's all about finding that there is this partition. Do you guys have any doubts? If I have 100k subscribers, I would do that. Okay, Prismax. It might be a nice problem, but now the stream is on LeetCode problems, right? See, it's accepted. 2024. See, it's accepted. See, 1900 problems can be this simple, and you niggas go, what topics do I need for 1900 problems? Like, do I need that Kruskal's algorithm or like some other algorithm? What is algorithm? You need logic. How can this one have any algorithm? I should. I think if I grow my hair back, I will get my rating back. How to grow my hair? Where are we? So, guys, so far any doubts? On an average, we took 14 minutes for two problems. Duel with ARPA got postponed. On an average, I took 14 minutes per problem, like considering 28 minutes so far. So I have to be quicker, guys. I don't have time for this shit. I have many things to do. Longest balance subarray. I will also confirm if this is the exact problem. We're at Monday. Nah. Whoa, 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 whoa. Let's not do this thing. Let's go here. So Sunday is done. Balanced binary tree. Now it's balance is binary search tree. Given a root of a binary search tree, return a balanced binary search tree with the same node values if there is more than one answer. Is this like we have to do rotations, or like we have to, so we have to change the tree? Damn, how is this a medium problem? Isn't this hard? See, the thing is, we can either like, can we create new nodes? See, the problem can be done by trying to just manipulate it and then balance it properly, or the problem can be done by take form some other balanced binary and then fill the values. But that is not the right approach, right? But let's just do that. Okay? Form a balanced binary tree and then just fill in the values. Let's say you have, so what did I mean? We have a tree here. We have a balanced, we have some tree. Let's not care about what is this tree. I thought we can try to balance, we can try to find the mid value or something like that, and then try to balance things like that, by trying to go till here and then keep this one side. But instead, the only ask is use same values and balance, right? So what would we do is we will construct of size n. We know the size already. We will construct an equal tree like this. Okay, how does that start? 1, 2, 3, and then 3, 4, 5, 6. Let's start a tree like this. Okay, this tree will at one point it will end, and then what do? We keep 1 here, we keep 2 here, we keep 3 here, and then we keep 4 here, and then we come here 5, 6, 7, and then we go here 8, and then we repeat the process. Okay, we can do this recursively. First you have to fill, you have some value val, from here you have to fill in the values, and then what do to fill in the values from 1? What do? First you will try to fill here, fill left subtree, and then fill node, and then fill right subtree. So first goal is to make this tree, and then the next goal is to, fill in the values. We don't care about memory. We will completely make new nodes. Okay, we will completely make new nodes. We want these values. We want what are these values. We will make new nodes and then we will fill these values. Okay, that still works. Even the memory is a lot. We are taking new nodes, but that works. What do? First, we want ordering of these things. Like we want all these values. We can sort them, or we need not sort, or we can go to the balanced binary tree. Okay, is it not balanced or is it balanced? Binary search tree is like already balanced, in the sense like, sorry, is this sorted or not? Balanced. Can I get some water? I'll go and get some water. I'll go and get some water, guys. I won't do that. That's too complex for now. See, it's not even DFS. It's so simple, right? Because it's balanced. Balanced means, or not balanced, because it's a binary search tree. What's the property of binary search tree? The same one that I have used before. All these values less than this value less than all these values. That's what binary search tree property. So what should we do? Recursively first push these things into our vector, our list, and then push this one, and then push this one. That's what it is. Like, okay, get values. Let me write one thing called Let's say we have this vector int vals, okay? Void get vals, void find vals. Okay, if root equals to null, return. Else what do? We first find vals of, and then we find val, and then we push, and then we find vals of done. That's, this will just find this list first and then pushes this value and then finds this list. Recursion is that simple. Like code is always look, code will always look simple in recursion. Okay, now we have to balance it. Now we have to form a new tree. Let's try to form a new tree. Okay, how do we form a new tree? We want to form this graph: 1 node, 2 node, 3 node, 4 node, 5 node, 6 node, 7 node, up to so on. So how do I form that one? We need size, right? So what I will do is first I'll do find vals of root. Now we have int n equals to vals dot size of. So now I will try to form this one entirely new one. Okay, uh, or we can reuse those nodes. Should we reuse those node pointers instead of finding new nodes? But that is just too much. Let me try that. So I'm collecting those node pointers, okay, just for fun. And then we will replace the pointer values as we like. So we are just collecting those nodes. Like what are we doing? What the fuck is this one? Yeah, I don't know what the fuck is that one, but yeah. So we have these nodes, like we have these nodes, right? The pointer just points to the node. Instead of creating this node again, I'm trying to just take their addresses first and then I'm putting them in a list. Now I'll reorder them. Like before, this may be pointing to that, but now I will reorder them. Okay, now how will I reorder them? Just look at this. How will I reorder them? Okay, root of left, not root. Okay, tree node star ptr equals to nodes of I. Let's say now I have to point its left and right. Okay, now I have to point its left and right. What would I do that? How would I do that? I'm trying to guess you. How would I do that is, ptr of left will be nodes of 2 times I plus 1. ptr of right will be nodes of 2 times of I plus 2. So 0 will point to 1 comma 2, 1 will point to 3 comma 4, 2 will point to that, everything will point to that, and then we have that tree that we want to form here. We have this tree. 0 will point to 1 and 2. 0 means node 0, the previous node 0. Now we have to reorder values. Okay. We can take some int idx, like from where you have to reorder, from where. Okay, from where you have to reorder. Where in the list, from where in the list you have to reorder. Okay, else what should you do? You have to first fill values for the left subtree. And then idx will also increase to the next value that should be added. And then what do? You will add value, you will set value of this one. And then what do? You will fill right subtree. And then the problem is done. Here you have to do idx plus plus. Because this value is filled, you have to fill the next value. And that recursively handles everything. But be careful here, you have to use here nodes of 0, not root. See, it's very important you make them null. Otherwise, the tree may have loops, cycles, and then it will not be the right one. It will not be correct. It's accepted. Let's submit and see if it will get accepted. See, codes are always simple. They are cute. Like, see how cute is this? Find values as a list. Also find the nodes, and then just set them like this, like reordering nodes, reordering the pointers, and then just like filling them again recursively. Fill vals, find vals. Yep. What do you need it from whom though? We again took 14 minutes. 28 plus 14 equals to 42. Isn't this small? And let's go to the next daily problem. Okay, what have we done now? We have to take our red pen and then we have to cross Monday. Monday is worse, right? So let's cross it more. And what have we done here? Again, recursion, reordering, nice. I2 2i plus 1 comma 2i plus 2. So let's go to Tuesday. I'm trying. Longest balance subarray 1. You're given an array nums. A subarray is called balanced if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers. Return the longest balance subarray. Oh, we want number of distinct even numbers to be equal to the number of distinct odd numbers somehow. And then we want to return the longest balanced subarray. How will you solve for one array? First problem. How will you solve for given an array? How will you solve? If you know number of even distinct, you count. Given an array, how will you say if it's balanced or not? Count distinct, even, distinct, odd. Oh, number of lengths is very small. We can do n square. That's why we have to see constraints, guys. That's because it is one. In two, constraints will be more difficult. So because it's 1, let's just do that. Let's let answer be 0, and then from j you are starting. Okay, from I you are starting. Let's say you're trying to think about the problem from I, and from I, if you're trying to think about the problem, let's just maintain sets of o comma e. Okay, if of nums of j equals to, reminder 2, o dot insert of nums of j, else e dot insert of nums of j. If o dot size of equals to e dot size of answer equals to max of answer comma j minus I plus 1. So this is a brute force one, but that covers all of these things. Oh, we took less than 14 minutes for the first time. How much is it? 14 seconds this time. What is Tuesday? It's a joke somehow. It's just a joke. N squared brute force. Is Wednesday problem harder version of the same problem? Damn. Do we have two more funny problems, three more funny problems. But the constraints are higher here. So if the constraints are higher, we still have to use the previous things a bit, right? Mm-mm-mm-mm. So yeah, how would we do this? First thing, can we binary search? Maybe or may not be. We don't know properly. See, when can we binary search? When can we binary search? So let's say you're trying to find something, okay? We want to find the maximum size, right? Maximum size for a balanced one. So given that this size exists, like let's say you have sizes 0, 1, 2, 3, 4, or 5, to so on. Given that this size exists, okay, given that this size exists, this is the maximum, and after this there is nothing existing, all of them are reds. It looks like a watermelon, right? A bit because of the green and reds. But if all of the previous things are green, means if you can prove that if this is there also all of them will be there, then you can do binary search. You should not randomly think of binary search. You have to see, okay, sometimes it's obvious that because if this itself is possible, the previous things are also possible. You can say that sometimes very easily. But here, can you say that? Can you say that if some bigger length existed where maybe not, right? Because just think of it, think of this thing here. You have one, two, two, 3, 4, 4, 4, 4, let's say. You have this big length, but you don't have all other small lengths, right? The next things that are possible are, you don't have 3, you don't have length 3. Length 3 is never possible. I mean, yeah, length 3 is not possible here. Length 3 is in general, okay, we have length 3 also. Okay, but if it is actually possible, what's the logic? Yeah, maybe we can binary search on that. Let's think about that one, okay? Let's say you have even here, you have even here, and then you have odd here and then odd here. Number of, you have even, you have odd, even. Can you always have something left length, number of even being -1? How do you prove that? Let's say there is existed something like this. How do you prove that there is something smaller? Always. How do I prove it? First, I will try to see. Now, what I'm trying to do is, let's say there are multiple occurrences of some even value. I will only look at last occurrence because that's enough for us to solve the problem. Because a subtree. So let's look at last occurrences of all even values, and then last occurrences of all odd values. The thing is, even in this thing, it should be possible. Even in this thing, there should be a subarray of smaller size. So, because, I mean, see logically, the cases of multiple things will have cases of single things. Like we have multiple things and single things side by side. If this is side, this will be inside this too, and then even that should be having some subarray. See how I'm trying to just conclude, come to here, because if this is passing, this also should go, this also should always be true, right? Even for unique even and all things, it should be true. And for multiple things, we can just look at the unique values and then we can try to see if there exists on that. So if you can prove for this, it's done. So let's say you're trying to see if there is something smaller. Okay, this even has been removed, and then if the last one is odd, that odd can be removed and then the problem is done. If the last one is also even, so now you have to worry about. That's why I wrote this case of even, odd, even. Now let's try to see even. So you have more odds here. Can you somehow remove an even? Can you somehow remove an odd by maintaining the even ones? Is that possible? Was it possible here? Even here it was not possible. This itself is a proof, right, that it's impossible. So let's show that proof again. 2, 4, 1, 3, 5, 7, 6, 8. See, it's not possible. You have this one, but you cannot have anything smaller. See, if you remove this, you cannot remove one more odd by maintaining other events. So yeah, you cannot do binary search here, because you have a case where you cannot do binary search also on number of events and number of odds. Because if you remove that one, there is no way you can remove one of the odd without removing these things. This is possible, but that is of length 2, not size 3. Yeah, got it. Like we can solve the problem. I'm just trying to see if binary search works or not. Like I'm trying to explain things here, guys. I'm not struggling. Okay, I can solve the problem. I'm just trying to be more explanate you. Like I wanted you guys to understand a bit more on binary search. Okay, whoever that are watching the video, values are also small. All you care about is even or odd, right? Can you brute force some starting index and then think about the answer now? I mean, I obviously know one segmentary answer which I got it like when I'm solving the previous problem itself. So let's say we are brute forcing, not segmentary, like we are brute forcing R. Okay, we are brute forcing R, and let's say you are here. I'll use this itself to explain. Let's say you're brute forcing R. See, when the problem looks complex, it's mostly brute force. You guys cannot put the mental effort to brute force things, and then you guys think you're not getting good ideas. It's just that you're lazy to think. Okay, it's just that you're lazy to think. Like you have to just push yourself a bit more in everything you do, then you will do better eventually. It's not like getting great ideas, because brute force is work, right? Most problems are brute force, like, and then you guys think brute force means brute forcing everything as the problem told. No, brute forcing means what do you brute force? Only brute force R, and then you don't brute force the left side as it is, but the problem is brute forcing R. You have to think like that. Okay, when you're at R, you're trying to see all the subarrays that are ending at R. Okay, now for each odd value, okay, for each unique value, let's say you will try to keep its rightmost occurrence as 1 and all other things as 0. This is very common thing to do. The rightmost occurrence, I will keep it as 1 and I will keep everything as 0. Because we are trying to go from here, only this will matter, right? We are going to see from this side. Only this one will matter because these things are already came. So if you can keep 1 here and zeros here, okay? And if you can keep minus ones to all even values similarly, okay? Now what do you want? You want some subarray whose sum is 0, and you want maximum such subarray. You want some maximum such subarray, but the values are changing dynamically. It's not just maximum subarray problem, because as you go further, as you change your R, as you increase your R, you're trying to change a value of something. You will make that shit 0 and then you will make that shit 1. That's why we may need segmentary, because we are doing updates. Okay? I don't even think segmentary helps. Like, I don't know how to solve this for now. Sorry, guys, for this. I don't think even this is easy. Like, how do you maintain all prefix sum? See, to get the maximum sum to be 0, if this prefix sum is this value, you want the same prefix sum somewhere else. Using that, you can find this one. But when a value changes, prefix sum of all these things change. So you cannot update prefix sums of all these things and still maintain. I mean, using segment trees, you can somehow do that, I guess. What happens is all the values for prefix sums, let's say you're focusing on prefix sums, you're maintaining prefix sums in a segment tree. When this value changes, all these things will change, and then this also will be added. So you're doing some range operation, and then you want first occurrence of some particular value. So what do you need is range operation and first occurrence of leftmost occurrence of some particular value. But this is not easy, right? I mean, for I'm trying to guess you. That's not GF. That's work. Okay. Not my company's work, but yeah, it's work still. Yeah, number of distinct, odd, number of distinct even. That's why I'm making these things as zero, right? I'm trying to make these things as zero if they are same value, and I'm trying to make this as one to keep them distinct. Okay, is that clear? So guys, what will I do? What will I do when segment tree becomes a bit complex? We have just 11 viewers, even though we are getting premium content here. Too bad. What do you guys think I will do when segment tree seems a bit more complex? I thought of some other thing, and the solution is already working in my mind, obviously. Because these two operations, like range operation and then getting first value, you're increasing a range and then you want prefixes where in this array where prefix occurs in the beginning. This thing looking a bit complex. Like, do I go for lazy segment tree, where I think even in segment tree if you store for each, so segment tree divides the array like this, right, into halves, into halves, into halves, like that. Segment tree is same as divide and conquer. Actually, segment tree is the idea of divide and conquer, but maybe a bit not powerful. I cannot say segment tree is more powerful. Segment tree is from divide and conquer. Like, segment tree is divide and conquer supplication. Like, you guys will never realize that. You guys will throw away the core concepts like greedy algorithms or like dynamic programming or like divide and conquer, which is even more better than other things. And you guys will remember segment tree somehow. Segment tree is pure application of divide and conquer. Like, it's like you divide things further and further in segment tree. Okay. No, I will use divide and conquer. Okay, I will divide and conquer. See, divide and conquer, you may try to think of divide and conquer in very big algorithms, very difficult problems. But even if it's an easy problem, if I can do divide and conquer, I will prefer that one, because that's like med sort, right? That's how you do med sort. So so now let's try to think of divide and conquer a bit. Okay, now you have your array. Now you're trying to think of dividing it into two parts, and then think of recursion. So recursion will give you all subarrays here which are good and maximum answer. Now you have to worry about subarrays that span across these two parts. Only those things you have to worry about, right? And if you're trying to worry about those things, you have one side that goes like this. You have the other side that goes like this. Okay. And now Now you will try to apply that same logic that we are trying to apply before. If it is odd, you will keep this one 1 and you will keep all these things 0. If it is even, you will keep this one 1 minus 1. You will keep other things as 0. Now you have some prefix sums here. Similarly, you have some suffix sums here. Right? If this suffix sum plus if this prefix sum equals to 0, that gives you a good array. Can you solve this problem now? Because all these suffix sums will take values from minus length to plus length. All these things will take values from minus length for L2 to plus L2. And then you have to see for each value what is the maximum length where it occurs. Okay? So you have that value for each length, and then you have this value for each length too, and then you will just pair them up. You will see for this one if there exists that opposite length, and then you will add those two lengths, and then that you have the answer. Do you guys get the solution? How powerful divide and conquer is? How powerful divide and conquer recursion is? Have you guys gotten this? I am not in college. I'm working. Yeah, it's a nice one, right? We have to explain it again because divide and conquer is so basic, but we don't use it. Yeah, it's always made logic like, you, see, I prefer divide and conquer whenever possible. I have done such algorithms before. I have done such algorithms before too. And it's fun writing. What's so fun of using segmentary? I see some masters or candidate masters glaze on segmentary, like segmentary is so beautiful. What's beautiful in trying to use something that is already abstracted, like use something that's already done? This is more beautiful to not use anything and still solve the problem that appears so difficult in other sense, right? Knowledge, how is knowledge that beautiful? Like, where is beauty there? They just glaze at it for no reason, I guess. This is beautiful, right? So I'll explain it again. You have these two arrays. You are splitting that array into two halves, okay? Let's say this one is L1, this one is L2. Almost both of them will be very equal. Both of them will be almost half, okay? Half the size. Both of them will be half size. Now, all the subarrays that are here, you will get that recursively. T of n equals to T of n by 2 plus T of n by 2 plus, if you do O of n operations, the total complexity will be n log n. This is the recurrence relation like for time complexity of divide and conquer. Can I try to select and move this away? I'm trying. So now we have to worry about subarrays that span both sides. Okay. Subarrays that spans both sides. Now if you try to look at that one, for these subarrays, we can't do this because if the same odd value is here and the same odd value is here, you cannot do this thing. You cannot put one here, you cannot put one again here, and then you cannot say these both are unique. It's fucked, guys. I'm sorry for this. I'm thinking if you can do with respect to values, can you split with respect to values is what I was thinking. Let's still try. I assume that values on this side and values on this side are distinct. because you can have same value 1 here, and then you cannot just put 1 on this one, and then you cannot put zeros on this one, then you cannot put 1 on this one, and you cannot put zeros on this one. But divide and conquer many times solves things easily. I'm getting sleep somehow. I'm trying to kiss you. Had to listen some other song. Let's go to other problems and come back to this one. Okay, let's not waste time. We will solve this problem, but let me go to some other problems and then come back here. How did it turn out to be? Not too difficult. Like it's a bit. See, using segment tree, we can somehow do that. Range operation, and then you have to find the first occurrence of this thing. Maybe using n-root-n algorithm. Can some n-root-n work? I think n-root-n is also good than segment tree if you can. If you can make it work. What is time limit? We know how to do segment using segment tree. We will lazy update and then we'll try to find the first occurrence. I don't know if it is even possible to do that, but can we still try divide and conquer in some way? Can we still try divide and conquer in some way? So now we have to just we have this side this, let's say we are fixing this one. Okay, we fix it this one. We know what are all odd values here, we know what are all even values here. So we know what all odd values here, we know what all even values that are here, we know their count, we know everything. Okay, if we are fixing this one, now we are trying to look at these things. So once you fix these ones, let's try to remove these values from here. Let's try to remove those values first. Okay, we first remove those values. Now what do we need? Now we need now we need in prefix sums, we need same problem almost. In prefix sums we need where if same value comes again, because it's already removed, we don't do anything. Okay, now it's again seems the same problem somehow. Like you want maximum length where the sum is equals to, let's say this one is plus ones minus ones, like the difference is there, right? You have to go for minus difference on this side. Where will that happen? You're trying to do these updates. Okay, you're trying to do those updates. You cannot do n square. As you are varying this one, you cannot go again and then update them. We want to update and then we want some prefix sum very quickly. So it's segmented brute force itself, I think. See, there is no idea here. Like, okay, It's not Friday night, it's Friday evening. See, there is no idea here. Okay, okay, Ari. Let me see the two other problems and then come back here, okay? In the worst case, I will try to see if segmentary is possible itself. See, it's not a good problem. Definitely not a good problem because I don't think there is anything nice in here that we will find and then we will solve. It's likely updating the range lazily and then again trying to go and find updating the range lazily, and then you can divide. I think it's updating the range lazily, and then for each range, if you have set of values, okay, if you have set of values plus, if you have set of values plus, let's say you have set of values in a set, okay, as a set, multi-set, let's say, so that you have value comma index, so that initial index also will be there, and then you have this plus some summation, because we may do this lazy addition, right? Then all the set values will update. When all the set values will update, you will just update it like, okay, this set must be added plus sum. So because you cannot update each value in the set, you will just keep this such a thing. So you will have a segmentary here, okay, where each segment also has a set. Why we need this set? To quickly get the index of a prefix, okay, and we will also have some sum, because values will be off shifted when you do some lazy operation to add something to a range, right? Now you can do range operations where a range will be updated, and when you're updating a range, whenever you reach a segment, you will say the whole segment must be updated, and then you won't do that. You will just keep that set s plus in this format. You will just keep the set, and the next time you come here, maybe you can push the lazy things down. In that way, you can try to see if there exists this set or not. Like, you can try to just query this set and see if you have pref or not. Okay, now because you're having sets, now what do? You want the first occurrence of pref, so you divide it into two parts. In this segment, you will ask if pref is there or not. Here you will ask if pref is there. If pref is there here, I'm thinking what happens when you update a set here? How will you update the top set? You cannot, right? When this one becomes plus s, you cannot update these values in the top set so easily. See, it's definitely not about idea. CF problems are good. These problems are shit, okay? In CF, difficult problems are not difficult because of you have to use something. They are difficult because two negatives. I'm tired, guys. Let me go to next problem. We have Thursday, Friday, okay? Longest balance substring 1. You're given a string as consisting. So this is done already. Also, this is done. So these two were done long back. Guys, check out my old videos. They're already done. That's how you should practice. Before opening the problem, you should be solving it already. I love Mickey Mouse. So we are left with the same problem again. Same stupid problem. I'm trying. So how to solve this one? Should I go n root n? Should I go n root n and then sets? What do I mean by n root n and then sets? So uh, the same idea that whatever we are trying to do, the lazy set addition thing, right? Let's split the let's split the thing into let's split the thing into root n segments, okay? After that, now think about and for each of them we will maintain a set, okay? Now you have these root n sets. We will maintain prefix sums, okay? And when we update something from +1 or -1 to 0, and then we will add a new thing. What are we doing? The whole range will get updated by +1 or -1. So we have to update the whole range. So what do we do? Along with the set s, we will maintain a sum offset. So for the range, if the range is long, what do we do is we maintain the offset, we update the offset for complete ones, and if something is falling in between, for that we edit the offset, we make the offset 0, and then we update the individual values and then we put them back in set. In this way, we can maintain a set and an offset for each of these root n segments. And if you are maintaining this data structure, so these are data structures, guys, where you try to maintain some data to be able to do what you want to do. You can do in root n operations, root n log n operations, because okay, update is easy. Update is root n operations. Update is root n operations because you will come here, come here, come here, and then plus each of this you will keep in set. Update is root n log n because you are keeping root n things into the set finally. And sum is not sum, first value. Even this is root n log n. You will go to these root n segments and then you will try to find the first occurrence. The first occurrence, yeah, you can try to just find if it occurs or not occurs or not. If it is occurring, then you can go and just check individually. You can go and check individually if in root n operations, if where will it occur. So you can do it in n root n log n. Let me write that in green so it doesn't look too big. In this complexity, we can do that update. Should we go for this? It doesn't fit frame, bro. If I have to show in this small frame, it goes like from here till here. Do you want to see my banana? It's much bigger than this, though. It's obviously bigger than this. We don't have big bananas except mine here. Glaze. What does glaze means? Glazing. Nah, I cannot eat this in front of you people. I can't be eating this. I'll turn off the video and eat this. Mm-mm-mm. Okay, should we go with enroute and login? Should we go with enroute and login? Hey guys, should we go with enroute and login? We should give that a name because names are fancy for this LeetCode people, right? Square root set composition dissatisfy what decomposition we have to involve set decompose section. How is that? Set based srd. Set srd. I have to go to gym after this to maintain my mighty muscles. They're not being visible here, but they're like good. But why is it not visible here? Apps too. See guys, this is not some porn stream where you say show apps and then I show apps, okay? If you have sent 5 rupees and then said show apps, it would have been even better. I don't do big weights somehow. I have nice pictures. I cannot show apps directly, but I can show my app pictures. I haven't used persistent segmentary. Maybe that solves this one. So you have apps like this. So I have apps. So yeah, should we do root and set or not? Say guys. Should we do root and set? Should we go ahead and do root and sets? Like we maintain root and sets and root and login. I have to improve my bench. I can do handstand. I can do handstand push-ups a bit. My fitness channel incoming, like. I thought I will do 1 year of coding streams and then 1 year of fitness streams. Okay, fitness content. So 1 year of coding is about to be done in few months. Then I will stop coding entirely. I won't do any coding streams. I will take a gap of 2 years or 1 year, and then I'll start OnlyFans. This 1 year of coding is to gain some fans, and then I'll do an OnlyFans, and then I'll live off that. So we will do square root decomposition on this shitty problem itself. Okay. We have prefix ranges, we have n root and sets, we have two things to be done, which is one update, range update, and range. We have range update and we have range update and hey, just think about this thing for once. Just think about this thing. Think of this thing, guys. We need not maintain a set here. Set is not needed. Why? We have a special property here. We have special property of ones and minus ones. The sum at max changes by 1 or minus 1. Do you see that? Sum at max changes by 1 or minus 1. If you use this shit, if you use this one, if you know min value and max value, you can say for sure that if you know min value and max value, you can say if pref of x exists or not. Okay, this problem became a bit better problem with segment tree. I can do this using segment tree now. Maintaining min, maintaining max, lazy, range operation. These things I think now it is a bit good. At least it's not maintaining sets. See, only fact that we have is that we haven't used it. The values are minus ones and plus ones, right? Values are minus ones, comma plus ones. So prefix values will at most change by plus one and minus one. And if you want to see if there is a value in between, if you know min, if you know max, you're great, you're done. That's it. I can even copy paste some code like that. Or I can write it on my own too, lazy. Or I can use a template. So guys, we are solving this problem using segment tree. Quick and well. Using the fact that values don't change much. That's genius. That's not genius. But yeah, it's all about using what we can use. Yeah, that's good. After all this struggle, that's definitely genius. After all this thinking we cannot solve that, it's right there in front of us. What is so specific on the problem? The problem is just plus ones and I actually thought can we use plus ones and minus one long back because it's plus ones and minus ones. But now, yeah, because it's just plus ones and minus ones, we can just have min, max, and then we can do it quick. I'm learning C. See, improve your skills. Whatever skills, if you're improving skills, things will automatically work out. Like you need not focus on job that much. Okay. Even if someone has made a complete playlist for a job, to how many people that might have actually helped to get a job? It might not, right? Try to improve your skills. Maybe try to improve your logical ability. Try to improve your math. See, you cannot do things for a goal. Okay, you have to put. If you're doing things for a goal, maybe you'll only watch that playlist. But if you're just doing it for doing it or like to do something or to just live, then you can do more than you can imagine. Okay. So the thing is, try to learn something. Try to have a clarity that okay, I have learned this one. Okay, I have learned this one. Okay, I can do some small coding problems. Have clarity. Okay, have clarity on what you can do, and then try to improve a bit more, and then have clarity that you can do that. You have to have like self clarity on what you have done. Okay, you cannot gain clarity by trying to see something. But okay, I have watched this playlist. Now my clarity is that I have watched this playlist. You cannot be such vague in what you know and what you can do. you have to be better. Have to be better in the sense that you have to have very clear idea that okay, I can do this, I cannot do that, I'm good at this, I'm not good at that. You have to have that clarity. Okay. I remember my passwords well. I can write segment trees on my own maybe, but not much. Let's see this prefix some queries. What am I using? Wait, where are segment trees? Where the fuck are segment trees? No, I have a segment tree here. I have a segment tree that uses big things. Yeah, I used to copy templates from here, segment tree templates. Did they reorder things? Ah, yeah, this should be that. So what do we have here? We have min, we have max, we have maximum difference. This is not needed now. Okay. And we are having lazy. And what are we doing? We are doing additions. This is what we want. We are adding to a range. So we have range update, and then this update will actually do that add plus plus. So we have a range update, we have min, we have max. And then what do you have for query? For query, we are trying to get in a range. We are trying to get if L is greater than 0. We are trying to get maximum difference in a range because merge is giving us all three things. Merge is giving us all three things, but I can write one more query. I can write one more query to go to this half or that half, or this half or that half. Or we can even write binary, or we can even do binary search. We can even do binary search if you want. Like we can do binary search out of segment, outside of segment tree. Like, okay, if this one is having our pref value or not, you will get min, you will get max. You can check if that is having your pref value or not. Currently you're till here. Okay, this after updating till here, you know this value is pref. You're trying to find if pref is there before that or not. Okay, and then you can do binary search to find. You will see till here. If that itself is not there, problem is done. But if that is having, so till here it's having, maybe before this it's not having, you can try to find the first time where it is having, and that will be your pref. So we can use the same segment tree, and then it will be log n whole square, but we can use binary search. So we can just use this segment tree, and then we are done we are done with the problem. So segment trees are not that bad, they are good. Someone told me to think more, or like to write something so I can get what? What did it just say? So LeetCode doesn't let us do this thing. I just copy paste those things here. Initially, all the values are zeros, it seems. Okay. If all the values are zeros, min is zero, max is zero, and we won't be having our prefix, but our prefix can also be zero. Anyway, zero is anyway present in the very beginning, so that is good. We can keep everything as zero. Can you write here itself? So lost occurrence of n will have where this value appeared last time. Okay, and we will have this a of n that has 1 minus 1 0, 1 minus 1 base 0, based on odd, even came already. Okay, so we have this, and then we have our segment tree. This will be of size n plus 1. Also, this will be of size n plus 1. Okay, we will do one based index because we are trying to do prefix sums, right? S will be prefix sum of a. X is just prefix sum of a. So when you change a value in a, you have to update some range. Some range you have to update in segment tree S, and lazy will handle that. And each time you do a query for a range, you will get min, max, and this MD is not needed. Using min and max, you can find Yeah, using min and max you can find. I was trying to think, can I do the same thing using the divide and conquer approach? But yeah, let's keep that aside. Using min and max you can find you can see you can do binary search and you can find the first occurrence of the pref. Okay. So S is having zeros. Initially pref of that is zero. So we are good here. Now we have to take nums of I minus 1 if lost occurrence of val is 0. That means we have to put 1 or minus 1 here. A of I equals to 1 or minus 1 based on val reminder 2, else A of I equals to 0. Okay. What should pref of I be? So let's make sure that S of I is 0 here. Okay. Because it's not touched at all. Now what do we do? Range update of I comma I. So we're trying to update this range with what value? Range query of I minus 1 comma I minus 1. So we're just keeping it previous value plus A of I. So we have just done this one. Okay. But wait. What should we do is we have to keep this same. We have to keep this as same. Whatever happens, this will be the same. And we will make the lost index as 0. So let's write this better. And you have to update from there till here. From here till I minus 1 you have to update with minus of A of lost occurrence of, see, minus of A of IDX, because that became 0 now. So range update has been done. Okay. This thing can be removed now. And A of I equals to val reminder to 1 times minus 1. Now you just have to add A of I. This is setting the value. So update is done, guys. Update is as simple as this. You have made one thing as 0 and then you have updated the range, and then you're trying to update this one value. To update that one value, because it's prefix sum, you're trying to find the previous value and then you're just updating it. Done. So update is done. After update, what should you do? Pref, let's say pref equals to this one, right? We have to find the first occurrence of pref. Okay, we have to find the first occurrence of pref. Let's write a function bool okay that takes data z and val and then returns z dot min max. Okay, now we should binary search. Before binary search, let's only proceed if it is there at all. Data temp equals to s dot range query of 0 comma I minus 1. Okay, if not temp dot, if not of okay of temp comma pref continue, that means that exists somewhere, pref is somewhere before. If it is somewhere before, we can form using or, we can form some good balanced thing using or. We want to find the first one. Okay, left equals to minus 1, let's say, right equals to I minus 1, because right is possible, while left not equals to right minus 1, int mid equals to left plus right by 2. This is not binary search on the problem, this is binary search inside to do some small thing. Okay, it's not binary search on the problem. Temp equals to s dot range query of 0 comma mid, if okay of temp comma pref right equals to mid, else left equals to mid. Right is something that contains pref, right? So right is actually at pref now, and I is at pref. Answer equals to max of answer comma I minus right. Return answer. So this is log n square, but yeah, if you keep segmentary aside, how difficult is the logic? Not difficult at all. If you keep segmentary aside, because segmentary is doing its job, and then it's just updating a range, updating a prefix sum, and then finding the firstmost one. To find the firstmost one, we just did binary search. To find if something is there or not, we just checked if it is in between minimum and maximum. So all the logic is about the value is not changing much. The value is only going plus 1 and minus 1. Can we keep these things outside? Let me do this quick. Actually, they can be int itself, right? Because the values are not changing much. So let's go behind. Let's go before. We will remove this one and then we'll just use 1e9. What does this mean? Fa, fa. Now they will ask for money if I run it again. We have to be careful because here I'm using s of array, not s of length. So my segment tree is having some issues because that was actually built for this one, but now we are using size n. So because it was built for that one, let's use that itself. Okay, I know this thing existed in my segment tree, so let's use that itself. Now it won't have an issue, maybe. Yeah, it's working. Is anyone there at least? 31 people. Damn, I thought there will be 3 people. Today's question is done, Hitachi. Sorry. It was done in my long back video. Huh? So what are we getting here? The answer is 5 is what they are telling, but I'm telling that's not 5. All I'm saying, let's give her a chance. Oh, 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 oh. So these are the values, right? And what should be the answer? Answer can be 5. But when f equals to 0, 1, 2, 3, 4, 5, we are stopping at 3. Why are we stopping at 3? Let's print pref 2. How is this minus 1? This should be 0, right? Because this is minus 1, this is plus 1, this is minus 1, this is plus 1, this is minus 1. The sum should be 0. Are we not adding the sum properly? Are we messing something up here? Last occurrence of val equals to I, not 0. Who did that? So now it's passing, so we can just submit this. So if you keep segment tree aside, it's not complex for logic wise. If you keep segment tree aside, it's not complex. So what do you guys think the problem is? Is it n log n square is the problem? I thought n log n square should work. 996 passed. We have a way to reduce the complexity if we want to, but is that really required? See, instead of doing binary search and then again range query, we can write a function here itself. We can write a function here itself. Uh, int find find first occurrence. We int tl tr int l int r. What is tl tr and what is l and r? tl tr are the trees left and right, the current nodes left and right. L and r are the range that we want to search. Okay. So we have zeros at the end, right? We have zeros at the end, but the first occurrence of 0 is in the start. So 0 is fine. Okay. Let's just split the array itself. Let's just split the whole array itself. Okay. We have this whole range that we have this whole range, and then what do? We go to first half or second half. Okay. We go to first half or second half. So let's see in the first half first. Okay. If t of v times 2 dot mi, I'll write here. Okay. Bool if OK of t of v times 2, which is nothing but the left subtree, left node in segment tree. Uh, if this is OK, return first occur. So it is not there in the whole big array itself. Then return -1. Okay, or we can return infinite because it's not there at all. Or we can return n2. N also works. Else, if TL equals to TR means it is there and it is here itself. We form the first occurrence. Return TL. Return first occurrence of v times 2. Else return find first occurrence of v times 2 plus 1. Done. Find first occurrence will give us in of n instead of the binary search we have done. Find first occurrence of 0 based or 1 based, right? 1, 0, n minus 1. N minus 1 is n. Even this we need not check. 1, 0, n val. This is now n log n complexity. We don't even need TL and TR. We know the nodes, right? Oh, but we need that to find these ranges. Will this get accepted? It's n log n instead of n log n square. What? Why? Why is this wrong? It should work in the same manner, right? Our segment tree is correct. Likely this is being wrong. Because it is 0 comma n minus 1, let's just use it like this. 1 comma 0 comma n minus 1 comma val. It will handle internally. Hmm? Time's passing. The fuck? How is it passing here but failing there? What? Guys, this bug is happening live when everyone is watching. How can uncommenting something will make it work and commenting something will not make it work? See, how is this happening? Can I debug? Like, what the fuck is this? Like, if I'm trying to debug, it's going wrong. It's going correct. Okay, it's wrong with this one too. Let's see what is wrong here. For one, we cannot be doing that. Okay, for 1 we got first occurrence as 1. For 2 we got first occurrence as 0. That is right. For 3 we got, so the answer should be 3. For 3 we got first occurrence as this one, which is right. For 4 we got first occurrence as 4, which is also likely right. For 5 and 6 we didn't get first occurrence of these two values at all, which is wrong. Oh, it's lazy, right? It's lazy. Because it's lazy, we should not write our own things in templates. Because it's lazy, I think I should do push off v whenever I try to access the value of something. Before doing that, I have to do push off v, so that the value becomes correct value. Whenever you try to access the value of that, you have to do push off v times 2, because here we are trying to access the value. Before accessing the value, you have to push the lazy part. Okay, that's a lesson for us who don't use segmentary often. Now it will get accepted. I think I have to remove these things. Problem is shit, guys, but we don't know how to use segmentary properly. At least we learned it a bit. If it's a lazy segmentary, you have to push before accessing the values. And while you are pushing, you have to make sure that it stays within. This has nothing like, there is no joy in this problem. What did we learn to do? What did we learn to do? Nothing like. We have this solution long back. The only nice thing here is the value doesn't change much. That's the only genius part. Even Ari has told us. Ari Joshi, I made it Arshi. See, solution is just this length. Solution is just this length. Make some 0 minus 1. Make some this comes in even easy problems, right? We keep that one as 0, but here we have to do range update. For that we have to do segmentary, and then this is just binary search in a better way. How long did it go? 2 hour 19 minutes. Damn. I'm ending the stream. Bye. Have things to do. Bye, guys. Today's question I have done already. It's there in some long, long back video. Have done this problem long, long back. See? Can I remember when? I don't have any plans for Valentine. I don't think I'll have even if I have a girlfriend. I don't know. Maybe I mean I've asked not asked like I don't think I'm meeting anyone. Oh, tomorrow is Saturday, but still I would like to do my company's work. My company's work is being interesting to me actually. It's really like it's being a bit interesting. Like even today, because my PR hasn't gotten accepted, like I came here, but otherwise I would be doing that work. When is submission? October 12th, 2025. How many months ago is October? October, right? November, December, January, Feb. It's like 3 months ago. Who's this? Hello, bro. Yeah, I'm near my PG itself. Not active yet. I'm streaming. What the fuck are these ads? Who will enable ads? These many ads. See, these are the problems. Longest balance one, longest balance two. So I'll link this video there. I'll link this in comments. Okay. Great, Mikoyan. Were you a female? I didn't know that. We should not use the term female, I know, but yeah. What's wrong with that? Bye, everyone. Like the video before leaving. I'll go to gym likely and try to train a bit. No rest, guys. What's rest? No rest day, no rest from coding to work to gym. Females need rest. Females need Valentines. Why is it even existing? I thought it's like some guy slop thing. Like the video, guys. I'll leave. I don't know. Like maybe I may go out. Like maybe I will ask someone to go out. but I haven't. I was not focusing on that at all. Really. Actually, next wave is good, guys. They are treating me good. See, I meet girls often, but for Valentine's, I don't have any plans. Ask me anything, guys. You mean guys don't like this one? I'm just doing something for because I am bored. I'll leave, I guess. Bye.